All right, in today's lesson, section 7.5, we are going to be talking about different types of variation functions. And what you'll see, the reason this is connected to other stuff is because, primarily because of inverse variation and because of combined joint variation. So that's why it shows up here. It does feel a little bit awkward because we sort of shift gears from graphing rational functions into these different types of variation functions. We're going to first talk about direct variation, which I think you actually talked about probably at some point in Algebra 1. And direct variation is a relationship between two variables that varies directly. And the relationship is linear. Okay, so direct variation takes this form. If we say something like y varies directly as x, then y equals sum k, which is the constant of variation, times x. Okay, and so because this is, you can see this is a very simple linear equation. So you might have something like, as an example, y equals 7x, right, or y equals negative 1/3 x. All right, and that's the variation. Those are a couple examples of direct variation equations. You can see that the k, the constant of variation in these, would be the slope. Right now, these are especially useful in word problems, which you'll do a few of them, but not all of them are necessarily word problems because we can just get a little bit of practice when all of the context from a word problem is stripped away. So let's look at an example here. So y varies directly as x. That's the phrasing that we will use, and that tells you that the equation is going to take this form, y equals k times x. It says y equals 15 when x equals negative 5. Find y when x equals 7. So the actual question is, find y when x equals 7. So to answer that, it would be really great if we knew what the equation was, right? If I knew the equation, I can answer that right away. So for instance, if I knew that the equation was y equals negative 1/3 x, I could take 7, plug it in, and I could tell you what y was when x was 7. It would be negative 7/3. So I need the equation. And most of these problems, you need to find the equation first. Okay, so they almost all break down into two different parts. So to find the equation, I note that I have a point. I have y equals 15 and x equals negative 5. So I can use that. If it's got to look like this, I have y and I have x. I can use that to figure out what k is. So I'll plug in 15 equals k times, what did I say, negative 5. Divide both sides by negative 5, and I get k equals negative 3. So my equation is y equals negative 3k. Now I can use that to actually answer the question, which is find y when x equals 7. So that's part 2. Part 2 is actually answer the question. So that's going to be y equals negative 3 times 7, and that's y equals negative 21. Okay, so think of it, all these types of problems, you got to think in these terms of these two steps. It's very easy to make a mistake and try to mush them together, whatever. But first find the equation, then answer the question. Equation, then question. Equation, then question. Okay. All right, let's talk about inverse variation. Y varies inversely as x. And in this situation, this is where we start to see why this shows up here. All right, so for inverse variation, those equations will take the form y equals k over x. Okay, so here's just a couple examples. Be something like y equals 2 over x, y equals negative 9 over x, and these are just simple reciprocal functions, or even simpler rational functions. All right, and so, but the process for solving these problems is going to be the same. It's going to be find the equation, answer the question. Okay, so y varies inversely as x is given here. Y is 28 when x is negative 2. Find y when x equals negative 10. That's our goal. Figure out what y is when x is negative 10. If I knew the equation, so for instance, if I knew this was my equation right here, this top equation, y equals 2 over x, then I could find it right away. I could plug negative 10 in and solve for y. But I don't have the equation, so I've got to go get it. Right? So to do that, I'm going to use the fact that it varies inversely, and it must take this form right here. It must take the form y equals k over x. I'm given y as 28 and x is negative 2, so I can plug in y, plug in x, and then I can solve for k. All right, so let's do that. Let's plug that stuff in. So I get 28 is equal to k over negative 2. I'm going to times both sides by negative 2. And I get k is equal to negative 56. That lets me get the equation then. The equation is y equals negative 56 over x. All right. So I'm close. Now I just need to do part 2. Part 2 is actually plugging the number in and solving. So I'm going to take y equals negative 56 over x, and I'm going to plug in x. So negative 10. So negative 56 over 10. And I end up with y equals, over negative 10. So I end up with y equals 5.6. Joint variation. We have 4 different kinds of variation. The third kind is joint variation. Y varies jointly as x and z. Okay, so y varies jointly is going to take this form. Y equals k times xz. And again, this k is again the constant of variation. Okay, so just one example here might be something like y equals 5 times x and z. And this is where y depends on 2 variables, 2 different inputs, okay, to get y. All right, but the problems are remarkably similar to the other two. Suppose y varies jointly as x and z. Find y when x equals 9 and z equals 2 if y equals 20 when z is 3 and x is 5. So again, let's highlight the question that they are asking. They want to know what y is when x is 9, z is 2. If I had the equation, for instance, if I knew it was this equation, I could plug in x and plug in z and answer the question right away. I don't know that though, so I need to find the equation. That's step 1. So I'm going to set this up. I'm going to put in 20 for y. That's going to be equal to k times x times z, which is 5 times 3. So then I'll divide both sides by 15, because 3 times 5 is 15. And I get that k is equal to 4/3. Meaning my joint variation equation is 4/3 xz. From there, I can actually answer the question. So step 2 then would be to plug in x and z to answer the question. Find y when x is 9, z is 2. So y equals 4/3. X is 9 and z is 2. And when you solve that, you get y is 24. Last one. Combined variation. This occurs when one quantity varies directly and or inversely as 2 or more other quantities. This means that we're combining variations together. So let's look at number 4. It says, suppose f varies directly as g. This should say as g. So the first thing I usually do for that is I write down, okay, f varies directly. That means k times the variable. So k times g. So that's the first part. And f varies inversely as h. Inversely, remember, takes this form. So if it varies inversely as h, then h needs to go in the denominator. Okay, so you can see how you just kind of go in order, combine the pieces together. Then it says find g when f equals 18 and h is negative 3. So that's what I'm trying to answer. And again, if I had the equation, I would be able to answer that question. I don't, so I've got to go figure out what it is. And I'm going to use this information to find it. So I know g is 24, h is 2, f is 6. I've got to figure out what k is. So I'm going to put 6 in here. K I don't know. G is 24. H is 2. So this is going to be k times 12. So k, when I divide both sides by 12, k will be 1/2. And so then my equation then will be y equals 1/2 times g over h. That's step 1, find the equation. Step 2, actually plug the numbers in. So I'm going to get, so to figure out what, I'm sorry, F, it should be F. Sorry, F. Okay, so that didn't make it much better. Sorry about that. Okay, so anyway, I'm going to plug in F and 18 and figure out what G is. Okay, so F is 18, so I'll plug that in. I get 18 equals 1/2 times G, which is 24, divided by, oh, I'm sorry, I don't know what G is. G I'm looking for. And then divided by H, which is -3. Okay, so then I'll times both sides by -3, and so I'll rewrite this. So 18 times -3 is -30 plus 24, so that's -54. That equals 1/2 times G. Times both sides by 2 to get rid of the half. And so I get that G is equal to -108. All right. Now, the last thing I want to do is a word problem. And the word problem we have here is the length of a violin string varies inversely as the frequency of its vibration. The violin string pitches 10, violin string 10 inches long vibrates at a frequency of 512 cycles per second. Find the frequency of an 8-inch violin string. So let's call the length L. Let's call the frequency F. Okay, and if I knew, so this is the question I'm trying to answer, find F when L is 8. In other words, find F when L equals 8. Now the problem is I don't have the equation. If I had the equation, I'd be able to answer this right away. The length of the violin string varies inversely as the frequency of its vibration, so that means that the length is equal to K divided by frequency, which is F. Again, I'm just going in order. It says the L varies inversely as F, the frequency. I'm told then that a 10-inch long string vibrates at 512 cycles per second. In other words, I'm told this, that 10 equals K over the frequency, which is 512. Okay, so if I times those sides by 512, I get K is equal to 5120. And so then my equation is going to be L is equal to 5120 over F. Okay, so then it says, hey, you know the length is 8, so you're going to plug in 8 equals 5120 over F, and then we need to solve that for F. So I'll times both sides by F. I get 8F on the left is equal to 5120. I divide both sides by 8, and I get that F is equal to 483.6. Nope, I'm sorry. Gosh darn it. Got the wrong example. We get F is 640. Cycles per second. So, sorry about that. I've definitely had better videos. But that basically wraps up all of the different types of variation functions, including their applications.